If you have set up Nemoclaw, your agent is probably sitting in a locked sandbox right now. It can't reach the internet, no Telegram, and no skills. Today we are opening it up. We will set up network policies so the agent can reach the services it needs. We will walk through the OpenShell TUI where you can monitor and approve every connection in real time, connect Telegram, install skills, and then I'll show you exactly what Nemoclaw's sandbox stops that vanilla OpenClaw doesn't. Quick recap if you are just joining. In the last video, we set up Nemoclaw from scratch on a cloud VPS. We went through Docker, OpenShell, got the NVIDIA inference working, set up HTTPS with Caddy, and got the web dashboard running. I'll link that below in the description. And I've put together a free guide with all the commands and steps from this video. You can grab it from our full community. Now, before we start changing things, let me quickly explain how Nemoclaw is put together. Because once you understand the architecture, everything we do after this makes way more sense. There are three pieces. First, OpenClaw. That's the AI agent itself. It's the thing that reads your messages, talks to your AI models, runs tools, executes skills. It lives inside the sandbox and has this web dashboard that you have been using. Second is OpenShell. Now this is the security layer that wraps around OpenClaw. It creates the sandbox, which is isolated container where OpenClaw runs. It controls what files the agent can access, what websites it can reach, and how inference requests get routed. The network policy files that we are going to edit and the TUI monitor, both of them are OpenShell things. Third, Nemoclaw. This is the orchestrator that ties everything together. It's the CLI tool you used to set up everything using the commands like Nemoclaw onboard, Nemoclaw start, or Nemoclaw connect. It calls OpenShell commands under the hood. Now here's the key thing, and this is important for understanding policies. Your API keys, NVIDIA, Anthropic, whatever, they never enter the sandbox. They live in the OpenShell gateway outside. When the agent needs to talk to an AI model, it sends the request to local address called inference.local. OpenShell intercepts it, swaps in the real credentials, and forwards it to that provider. So even if something inside the sandbox is compromised, your real keys are safe. The policy file controls what else the agent can reach beyond inference. And the TUI is your window into all of this. You can watch every connection in real time. And that's the whole picture. Now let's get into it. Let me open the terminal, and I'm in. Okay, so the first thing to understand about Nemoclaw is that your agent can't reach anything on the internet by default. Nothing. It's like a computer with the Wi-Fi turned off. The only way the agent can talk to any website is if that website is listed in a file called network policy. Let me show you where that file lives. So the path is kind of long, so let's save it as a shortcut. You can follow along and copy paste all of these commands from this doc. I'll paste and run it. And now if we run ls in this directory, we can see OpenClaw sandbox.yaml and presets. OpenClaw sandbox.yaml is the main policy. It contains the full list of everything that agent can reach. And presets contains all of these YAML files. These are ready-made configs for popular services like Discord, NPM, Telegram, Slack, etc. Now let's look at the main policy file. And this is what this file contains. There's a lot here, but it's simpler than it looks. So let me break it down. Up top, there is a file system policy section. This controls what files the agent can touch. These are the only files and folders that agent can write to. Everything else like user, library, proc, etc. are read-only. Now the main part, network policies. First entry is Claude code, and it's allowing access to api.anthropic.com on port 443. Similarly, it's allowing access to these two endpoints. And look at the binaries at the bottom. Only Claude user can use these endpoints. If anyone else tries to reach Anthropic, example curl, Python, or anything else, it is blocked. Next we have NVIDIA. There are two endpoints for NVIDIA's inference APIs. Only Claude and OpenClaw are allowed to use these APIs. Similarly, we have the policy for GitHub. It contains these two endpoints, and only these programs can use it. Then we have OpenClaw's own services like ClawHub, OpenClaw API, OpenClaw Docs, and all of these allows only OpenClaw program to reach them. So even if something else is running in that sandbox, like a script from a skill, and if it tries to call clawhub.com directly, it is blocked. Only OpenClaw can. Next we have NPM registry. Only OpenClaw and NPM can use it. And then we have Telegram and Discord. So both of these are pre-allowed. So that's the whole policy. Now let me show you what this looks like in practice. Let's open the TUI. So you can use this command OpenShell term. Go back, paste and run. And you will enter this OpenShell mode. This is the TUI overview. It's showing gateway as healthy. And you can see the providers NVIDIA and OpenAI that we set in our previous video. There is one sandbox in the running state. Now let me drill down into the sandbox. To do that, we can use tab to go down, then press enter. And now we are looking at this Nemoclaw-sandbox. It shows all the rules, all the policies, etc. over here. And then if we press L, we can see all the logs. And these are the logs flowing from OpenClaw. Now let me go back to the dashboard and ask the agent about the weather. It says, I tried to get the current weather, but weather service isn't responding right now. And if we look at our logs, we can see that the action is getting denied. In fact, we can open one of these, and these are the details. So the request was being made to weather.in, and it was getting denied. Let's go one step back by pressing escape. And now let's look at the rules. So we will press R, and we'll start seeing these blocked actions. So two things got blocked here. First is weather.in on port 80. That's a weather service. The agent used curl to fetch weather data and got blocked because weather.in isn't on our list. And this 7x means it tried multiple times. Second is registry.npmjs.org on port 443. Now this is interesting because npm is in our policy. We just saw it. But look at the program. It's Node. Our policy only allows OpenClaw and npm to use npm registry. Node is the runtime that OpenClaw itself runs on. It's a different program from the npm command. So even though the website is approved, the wrong program tried to use it, and that's why it got blocked. That's the binary restriction doing exactly what it should. Now, if you look at the controls at the bottom, we have A for approve, X for reject, and capital A for approve all. Now we can select the rule by pressing up and down arrow, and then press enter. Now we can press A and approve this request, or press X and reject it. It will stay blocked until we approve it. But here's the thing. TUI approvals are temporary. They last while the sandbox is running. But when it stops or the gateway restarts, then they are gone. You can think of it like testing. Approve it to see if it works, and then make it permanent in the policy file. Now to make it permanent, we can follow the instructions in the next section. First, we need to open the policy file. Let's copy this command, and let's get out of TUI. We can press escape, and then press Ctrl+C. Let's paste that command, run it. And then we need to copy the policy for weather from here, go back and scroll down in this file, go to network policies section, and right before Claude code, we can paste it. Then press Ctrl+O, press enter, and then Ctrl+X. Now once the policy is added, we need to apply it. To do that, we need to run this command. Make sure you replace this Nemoclaw-sandbox with your sandbox name. Let's paste and run. And now the policy version was submitted. Let's run OpenShell term and get into TUI. Let's switch to sandboxes and then press L to look at the logs. And now let's come back to dashboard and ask it to try again. And this time it was successful. Let's look at the logs, and here we can see that the action was allowed. Great, so this policy is now working fine, and it will persist across restarts. Now one thing to keep in mind is, this OpenShell policy set command replaces the entire policy with whatever is there in this file. So make sure you are referencing the correct YAML file in this command. Alright, now let's add Telegram as one of our communication channel. We saw that Telegram is in our default policy, but if yours doesn't have it, to add these presets, copy these commands from here, go back, paste, and now it will ask you, which program do you want to set up? Then you can type Telegram and enter. Select yes, and the policy would be added. Now that we control what the agent can reach, let's connect Telegram. So the same process applies for Discord, Slack, WhatsApp, etc. To do that, you need to go to Telegram, open botfather, then run /new bot, give a name to your bot, and you will get an access token and the link to your bot. Next, we need to start the bridge. To do that, we need to export the bot token. Grab your token from here, paste it in this command, and enter. And now it's added. And then run Nemoclaw start command to start the bridge. Let's come back, run the command, and the bridge has started. Now to make this token persist permanently, we can add it to bash rc. Let's copy this command, then grab your token again, and then replace your token with the copied token. then run it. Now, does this need a policy change? No, because Telegram is already in our default policy. Right now, anyone could message your bot. Let's fix that. First, we need your Telegram user ID. And the easiest way to do that is just search for user info bot on Google, open the first link, open in web, and copy the ID from here. And after that, we need to grab this Telegram config from here, then go to our OpenClaw dashboard, go to config, switch to raw mode, and then scroll down to channels. Inside channels, let's paste the copied config. Let's remove the comma at the end, and we need to replace this your numeric ID with the ID that we got from user info bot. Let's paste it over here and then click on apply. OpenClaw will reboot and pick it up. And now if you click on your bot and send the message hi, you will get a response from OpenClaw. Now since the DM policy is allow list and only your user ID is allow listed, OpenClaw will respond back to the messages to that bot only from your user ID. Now the Telegram works and we can talk to our agent from our phone, but it's still just a chatbot. Let's make it more useful. Now there are two ways to extend your agent: skills and plugins. In the dashboard, under skills, you will see built-in skills. A number of these are installed and you can disable them if not required, but they're blocked with messages like missing binaries. And if you try to install one of these, you will see a message, go not installed or npm not installed. These are packages that you need to install inside the sandbox to make this work. Now, one important thing to note here is that in OpenShell term, we saw that in the rules, this npm.js org was blocked. So if you try to install those packages using npm inside your sandbox, it will fail. So one way to install skills is unblock it from here. Just click it, approve it by pressing A, and then you can install npm packages, and then come back here on this dashboard and click on install, and it will go through. But the safe approach is installing the skill on your host outside the sandbox, open that file, review it, and if it's safe, then you copy it inside the sandbox. So let's see how it works. Let's copy this command to first install Claude. We are outside the sandbox. Let's paste and run. And this has installed Claude. Then we can run this command, Claude install and skill name. Let's give the skill name as Gemini, and it will install the skill. Now it is installed at root skills Gemini. It is outside the sandbox. Then you can review the contents of it, and then you can move it inside the sandbox. You can either run these two commands separately, or you can simply copy this script from here and run it. It will move all of your downloaded skills to the sandbox. Let's execute it. And there were two downloaded skills that have been copied to our sandbox. Now, if we go back to our dashboard, refresh this page, you can see that Gemini is now installed. And for these skills to take effect, you need to start a new session so that your agent picks up those new skills. You can install plugins inside the sandbox because OpenClaw binary is allowed by the network policy. So you can run all of these commands and install the required plugin. One thing to remember is that even after a skill is installed, if it needs an external API, the network policy has to allow that endpoint. Installing the skill and giving it network access are two separate steps. Now we have got policies, Telegram, and skills are set up. But what if one of those skills is malicious? Does the sandbox actually protect us? Let's consider a real scenario, step by step. You install a skill, let's say Web Search Pro from Claude. It looks great, but hidden in the instructions, there is a line telling the agent to read your SSH key, basically a master password to your servers, and send it to an attacker's server. On vanilla OpenClaw, the skill will load, there won't be any approval, agent will read your SSH key, it will send the key to attacker's server, there won't be any network restrictions, there won't be any log or alert. But on the other side, on Nemoclaw, agent will use the skill, then it will try to read the SSH key, and it will be blocked. Sandbox allows access to only sandbox and temp. Your home folder, SSH keys, browser passwords don't exist in there. Even if it gets any data and it tries to send it to attacker's server, it will be blocked because that server won't be in the policy. Now let's talk about LLM models. In vanilla OpenClaw, you can set up multiple models for an agent. For example, one primary model and then a fallback model. But Nemoclaw supports only one model at a time. There is no automatic fallback. All the LLM requests flows from your OpenClaw to your OpenShell, and then the provider and model gets replaced to what you had set using OpenShell inference set command. However, switching the models just takes a few seconds. First, you need to create a provider. If it's already created, then you can run this command and set your inference to that provider and the model. You can check which provider and model is active by using this command. You can find the full command guide in my free school community, link in the description. Let me know in the comments what use case do you want to build with Nemoclaw. That shapes what we cover next. If you found the video useful, don't forget to like the video and subscribe the channel. Thanks for watching, and I'll see you in the next one.